internet feels invisible, wireless, floating somewhere above us, a cloud that we never question. But that's not how it works. Because almost everything you do online doesn't travel through the air. It travels through physical cables. Cables first imagined nearly 2 centuries ago, when engineers tried to connect continents with telegraph wires. In 1858, the first cable was laid across the Atlantic Ocean, connecting Europe and North America for the first time in history. It was built by a British-American project led by entrepreneur Cyrus West Field. The goal was simple: to send messages faster than ships could carry them, because at the time, communication between continents took weeks. Governments needed faster decisions, markets needed faster information, and empires needed control over distant territories. The first message took hours to send, but it replaced a journey that once took weeks. So they laid a cable across the Atlantic Ocean. It was slow, unreliable, and it failed multiple times. But it changed everything. Because for the first time in history, continents were connected instantly. Modern internet cables are engineering masterpieces. At the core, they are made of glass. Thin optical fibers carrying light signals, pulses of data moving at nearly the speed of light. Each fiber, thinner than a human hair, capable of transmitting terabits of data every second. Surrounded by layers of protection, steel, copper, insulation, and in shallow waters, even additional armor to resist anchors and fishing gear. All designed to survive extreme pressure deep beneath the ocean surface, where pressures can exceed hundreds of times the atmosphere above, in total darkness, with signals boosted along the way by repeaters placed every few dozen kilometers. But these cables don't spread evenly across the planet. They follow specific routes, the shortest, the cheapest, the most practical. Often running along existing shipping lanes or connecting major economic hubs. Because laying a cable across the ocean is incredibly expensive, and every extra kilometer matters. So instead of spreading out, they concentrate, and that creates a problem. Because many of them pass through the same narrow locations, just like global shipping routes. Places like the Strait of Malacca or the Luzon Strait, where dozens of cables can run side by side through a single corridor. And on land, they often connect through just a few landing stations, which means a single disruption can affect millions of people. The biggest threat to these cables is not war, it's accidents. Fishing trawlers dragging heavy nets across the seabed, ships dropping anchors, sometimes in the wrong place, cutting cables without even realizing it. Because in many areas, these cables are not buried deep. They simply rest on the ocean floor, exposed, and incredibly difficult to monitor. In 2008, multiple cables in the Mediterranean were damaged, near Alexandria, one of the most critical connection points in the region. And suddenly, large parts of the Middle East and South Asia lost connectivity. Internet speeds dropped dramatically, financial transactions slowed down, entire networks struggled to function. All because of a few accidental cuts in a single part of the sea. But sometimes, the threat comes from nature. Underwater earthquakes, massive landslides, triggered deep beneath the ocean floor. Volcanic eruptions, reshaping entire regions in minutes. Forces far beyond human control, capable of breaking multiple cables at once. In 2006, an earthquake near Taiwan cut several cables at once, triggering underwater landslides that severed connections across the region and disrupted internet across Asia. Countries like Hong Kong, Japan, and parts of Southeast Asia experienced major slowdowns. Financial markets struggled to operate. International communication was delayed. Entire economies slowed down overnight. Because when cables fail, the digital world has no easy backup. And then, there is the possibility of something far more deliberate: sabotage. Because these cables are not just infrastructure, they are strategic assets, invisible but critical to modern power. Countries like the United States, China, and Russia all understand their importance, because controlling information is as important as controlling oil or trade routes. In recent years, there have been growing concerns about dark ships, vessels that turn off their tracking systems and operate without being easily identified, as well as specialized submarines capable of locating cables on the ocean floor, mapping them, tracking them, and potentially cutting them. Not in full-scale war, but in moments of tension, because a targeted disruption could slow down an entire economy without a single shot being fired. And in a conflict, cutting just a few key cables could be devastating. So what happens if the cables go dark? Bank transactions stop. Payments fail to process. Stock markets freeze, unable to synchronize data across continents. Supply chains break down. Ports can't coordinate shipments. Containers pile up. Air traffic systems lose coordination. Flights are delayed, rerouted, or grounded entirely. Cloud services go offline. Data centers lose connection to each other. Companies can't access their own systems. Entire countries become digitally isolated, cut off from global communication. In a world built on instant communication, even a short disruption can cause chaos. To prevent this, companies are building new networks. Tech giants like Google and Meta are investing in their own undersea cables. Not just using the internet, but owning the infrastructure behind it. Because their services depend on speed, reliability, and control. Creating redundancy, multiple paths for the same data, so if one cable fails, traffic can be instantly rerouted. Alternative routes, connecting continents through new directions, bypassing traditional choke points. And spreading risk across the network, because the more connections exist, the harder it is to break the system. The internet was never truly wireless. It was always physical, always fragile. A global system hidden beneath the ocean, stretching across continents, through thousands of kilometers of silent cables, connecting billions of people, in ways we rarely think about. Every message, every video, every transaction, traveling as pulses of light through glass thinner than a human hair, across the darkest parts of the planet. And the next time you send a message, remember this: It might be traveling thousands of kilometers, crossing oceans, passing through multiple countries before it reaches its destination. All through a single cable lying at the bottom of the sea.